Hello, 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 hello. How are you? Hello, guys. How are you?
Hello, sir. Well, thanks, and you?
I'm good. I'm good. I'm good. How has it been going?
It's been going okay, has ups and downs. Sir, quick question. Tomorrow, any idea what timetable we're gonna be using?
The normal one, the Tuesday one.
Okay, so it's gonna be a double Tuesday this week.
Yes, because for the past couple of weeks there was holidays on Mondays, so then it became a compensatory like
To
uh
catch up.
Tuesdays actually. So there were more Mondays than Tuesdays, so they decided to take one Monday, make it a Tuesday to compensate.
Okay, that's perfect.
Yeah.
Thank you.
Yeah, sure. Let's just remind the other guys that we're starting.
Okay.
Hi guys, it's a compensatory Tuesday. The lecture is starting now. I hope you didn't forget to check your emails. All right, I just sent a reminder to the other guys, but we have no time, so I'll just get going. So guys, last time when we talked, I told you that we're starting a new chapter. So we're starting with the basics matter, but in matter we're starting with atoms straight from the beginning. So what is an atom, if I may ask anyone here? Let's just talk as usual from your own perspective. The guys are quite, yes, Andy, so you can talk.
From what I've learned, an atom is the smallest unit of matter.
Yes, yes. That's more like the same thing, yeah. So it's written there, atom is the smallest particles that make up matter are called atoms. The last of the smallest. So how does the structure of an atom look? I think you did this, or for some of you who didn't do science, but so let me try and find my annotator here. Let's start. Yeah, there we go. So this whole cycle right here, that's the representation of an atom, right? And then inside is what is called the nucleus. This part right here inside is called the nucleus, right? And then inside the nucleus, what do you find? You find these two, protons and neutrons, right? And then on the outside, what do you find? These, the electrons, right? So you must understand, in the center, it's what is called the nucleus. And in the center is where you find what? Protons and neutrons. And then on the outside, there lies the electrons, right? That's the representation of an atom. To top it up there, you must know that electrons, they are negatively charged, right? And then the protons, they are positively charged, right? Positively charged. And then the neutrons, they have no charge, zero charge. They are neutral. Hence the name that they are called what? Neutrons, right? Uh, Next. So they're saying, let's try and erase that. Use annotate again. Let's clear the board. They're saying the nucleus is neutral charges called neutrons and positive, the neutrons and positive charges called electrons. Uh, we've already talked about this. I've already explained how this part looks like in the cycle where it's found in the nucleus, right? Then electrons are the cloud that surround the nucleus. See, it's around the nucleus. Electrons are negative charges. Remember, they're negatively charged. Protons, positively charged, right? Neutrons, zero charge, right? We talked about this also. Now, There is what is called the periodic table. For the periodic table, let's go back to that thing. I want to explain. Right, go back to the previous page. It's something that always, right? Always, when you see this, an atom, you must know that the number of electrons is equal to the number of protons. Right? The number of E's, electrons, is equal to the P's, the protons. Must always remember that, such that at the end of the day, the charge is zero. The positive balance the negative. Right? It's more important. We now go. Now, there is what is called the periodic table, guys. So you know what the periodic table is? It's a list of all elements in the world which are made up of different atoms. You know, when you go down to the smallest unit of everything in matter, we say it's an atom. It described that an atom is electrons, is neutrons, is protons, right? For example, here, now, let's annotate side inside. These are the metals, right? This is the right hand gases. Right. As you can see, as you can see there, is lithium, sodium. You must try to know that's lithium, that's sodium, that's potassium. So these are the abbreviations for those who don't know. These are the abbreviations, right? And then at the same other side, these are helium, xenon, radon, all going down. Right. So you must sit down, read the book, where the abbreviations H, sodium, potassium, all these came from to understand. But no, is you are going to go and find this. Okay, H there is one. That means that means it is one electron, one proton. If you look at lithium, it is three. That means it is three electrons, all the way going until you reach whatever number is there. For example, when you look at Be, this one, that's beryllium. That means it is four protons, right? Four electrons, right? Now, before I move on forward, any other questions so far? Anyone who's suffering, anyone who, or people are okay for now? By the way, I'm so far away. Now, that's what they are saying here. They are saying a periodic table consists of known as elements. Right. Take note of the words. Right. Always take note of the two atoms known as an element, each one. Right. An element is a substance made up of only one kind of atom. Alphabet used in elements are called symbols. So, for example, what I was saying is hydrogen is represented by H. What I was saying it's calcium. Calcium is represented by Ca. Right. So an element is a substance only made of one kind of atom. Alphabet use the elements called symbols. Right. I see someone looking here. Let's wait and hear what they are saying. There's two people who have raised hands. All of you, can you hear me now? Can you hear me now?
We can hear you, sir, but you are cutting.
Yes.
Sorry? Hello?
So we can hear you, but you're cutting. I think it's your network that side.
Yeah, I think so too, because I'm not in South Africa. I'm away at the moment. So my network is also giving me a problem. But now, can you hear me a bit? Should I continue? We just have one period only, just to introduce this topic.
Yeah, we can hear you, Sam.
Okay.
For now.
For now. Okay, so
Yes, for now.
where we were now, we're talking about that the periodic table consists of 92 atoms, right? That's what we're talking about, known as elements. And then we say an element is a substance made only of one kind of atom, right? And then we said we all know the alphabet, right? A, B, C, D up to Z, but there's an alphabet that is used for naming elements. That alphabet is not just an alphabet, it's symbols, they are representations. And then I went on to say for hydrogen, except for example, for hydrogen, they use H, right? For calcium, they use Ca, right? For magnesium, they use Mg, right? That's what I was saying. And then we said each element has its number showing its position in the periodic table. That position is called the atomic number. This atomic number that they are talking about, right? Let's go back to the other one. This here, right here, this number at the top that I was talking about, that is what is called the atomic number. Atomic number. Those 4, 3, 23, 24, 25, 26, 13, 10, that is what is called the atomic number, right? So here is an example that they are trying to show you here. They are saying, for example, helium, as you can see, there is 2 on top. That is an atomic number there, right? That is the atomic number. Okay, let's try to move on to something better. Okay. So, can you still hear me? Let me confirm before I keep going.
Yes.
Okay, wonderful. So, you see, that's what I was saying. They are saying atomic numbers are arranged in columns and rows. There are 7 horizontal rows, right? With 2 elements in one row, 8 elements in row 2. So, let's go back and try to look at it, right? See, the first row that they are talking about is this row on top. It has 2 elements, you can see. That's hydrogen, a gas, and then that's helium, another gas. And then this is the second row that they are talking about. This one is 2, 4, 6, 8 elements, right? And so on and so on and so on. Those are the rows that they are referring to there, right? We went on to say 8 elements on row 2, we counted, we got 8, right? 8 elements on row 3 and so on until 32 elements on row 7. So you saw how the rows are counted going down and how the elements are counted in the rows. Now, the periodic table of elements looks like this. This is the formal one, right? The other one is formal, but it wasn't, there's not so much differences except for me who already knows, right? So you can see that's row 1 there that is represented by green on the corner here. That's row 1. Then that's row 2 here, right? That's what we were talking about there. And all the numbers that are on top there that we're saying, those are the atomic numbers, right? So look at row 6 extended. Those are called the lanthanides. You know what lanthanides? Those are metals, guys. Have you ever heard something that's people saying radiation, even in movies, radiation, blah blah blah. He was exposed to radiation. What happened? ETC, all that stories. Yeah, those are the lanthanides, metals on the down. They are full of what is it called? Uranium, most of them. So uranium is part of those elements underneath these ones here. If you look closely on your free time when you're sitting down there on the periodic table, on the lanthanides, that's where you find uranium, the most radioactive isotope that is known to men for now. All right. Those are the lanthanides which are represented in green circles down there. You can see that on row 32 down there. All right. That's what we're talking about. So what they are saying actually is that a periodic table is also arranged in a vertical column. That's what I was describing in the beginning. Sorry guys, let's see. I think maybe some of you, are you still hearing me before I continue?
Yes, we
Yes.
can hear you.
Yes.
Okay. People are lost. I can see some people don't understand that today is a compensatory Tuesday. You guys don't check the university calendar, eh? They never you don't check, you just go. Okay, let's continue. So they're saying a periodic table is also arranged in a vertical column called groups, making 18 vertical groups of elements. Right. The key point about groups is that they contain elements that are similar to each other. So what you must understand about columns is that they are families. That's what they are saying. Let's go back to the back where I was trying to explain to you in the beginning about the stuff so that it's clear. Yeah, right. So for example, here they are talking about the families. That's what I was saying with these ones here. Let me try my pen to make my pen work. I was saying these ones right here, these are the gases, right? Then I was saying these ones here, these are the metals, right? As you can see, there's beryllium, magnesium, calcium, right? As you go down here again, these are things like sodium, potassium, rubium, right? And then if you check here, all here, these are all metals. Nickel, copper is also here, zinc, right? So vertically, you get families, right? I hope you get that. Vertically or columns, you get families, elements which behave similarly. They have the same behavior, right? Let's go back to where we were now. Right, we now. So group one elements are soft malleable metals, like I was saying that they are metals. They are metals that explode when placed in water. So on the extreme left, the last group that was that I said it's metal, where there's potassium, this one here, where there's potassium, lithium, sodium, this group here, this is the one that they are saying is explosive. You know all those explosives used in the army and etc. These are the metals that they use there, right? They create explosives. That's what they are talking about there. Let's go back to where we were to continue. So group one elements are soft malleable metals that explode when placed in water. So you see now, if there is there anybody whoever watched what is it called, Breaking Bad? That father who was a gangster, a truckload. You see, you take your basic science and apply it out there. You can become even a terrorist through simple science that you're learning. So now you know that when you take group one elements, the purest form of them, and then when you place them in water, you know what's going to happen. Right? And they are also known as alkaline metals. So take note of these names, guys. Right? Take note of the behavior. Group one elements, my pen, yeah. Group one elements are soft malleable metals that explode when placed in water. These are the questions that come to you. Also remember that they are also known as alkaline metals. So that when now you're getting a question talking about alkaline metals, you say, no, Minera never told us something like this. We don't know it. Take note of the names. So group two, they are now called alkaline earth metals. Do not forget this earth inside, right? And then group 17 are halogens, right? You know, you're counting vertically on your periodic table, right? And then the last group on the extreme right, which I told you that these are gases, these are the noble gases. These are the helium that is used in birthday balloons. Have you seen birthday balloons? They'll be floating or flying in the air, right? That those are the noble gases, helium, etc., and onwards going that way, right? Let's try to on. Ultimately, each element has its own unique combination of row and column, right? Elements and groups, right? There is a diagonal band that splits a periodic table into two parts, right? This one you also have to listen and open your eyes. A diagonal band that splits a periodic table into two parts, right? So can you see it? There, they represented it for us so that it's clear for us. Right. Trying to get my pen to write. They are talking about this diagonal band. B represents boron. Yeah, when you now read on your own, you'll understand what all these abbreviations mean. AI here means aluminium, right? You see, going on and on and on and on all the way there, right? SI there means silicon. GE there means germanium, right? So let's go and hear what they are saying about this diagram. Hello, can you mute yourself or you want to speak? Thank you. So this diagonal divides elements into two metals on the left and non-metals on the right, right? Splits them into two metals on the left and non-metals on the right, right? So now we come to properties of metal. I think everyone knows the properties of metal. Is there anyone who doesn't know the properties of metal? We now know now that metal conducts electricity and heat, right? But it depends what kind of metal it is. Metals are shiny sometimes. Metals are malleable. Can somebody tell me what malleable means? Quick, guys. Someone just preface what malleable means.
You can change the shapes of the metal.
Yes, thank you. So for those who do not understand what malleable is, she just explained. This is the ability to agree to be bended, to change shape according to what you want, malleability, right? So they are metals, examples and classification of metals, right? See, Fe, that's a representation of iron, right? It's silver gray. Where is it used? Iron is usually used even with concrete buildings, cars, bridges, machines. That's the mostly used one, right? And then there's aluminium. Aluminium, we all know it. It's so light, right? It's light. It's a very good conductor. It's used in pots, window frames, boats, planes, vehicle bodies. It makes sense when they're saying boats, because that's where we need a metal, but a metal which is not dense, because it's light in itself. And then there's copper. Everyone knows copper. We know the story in South Africa. Copper wires being stolen. That's the best electrical conductor that there is, right? And then there's zinc, which is blue white. That's for galvanizing iron. I hope you know what galvanizing iron is. It's meant to protect iron from rusting. So when they say something is galvanized, they mean they've mixed it with zinc or they've coated it with zinc so that it doesn't rust easily. Because zinc is the ability to slow down or curb rusting. And then the last one is the favorite metal that everyone loves. The metal that makes people die in this world, gold. Right? That's for jewelry, coins, all the luxury out there, as we know, right? So now here are non-metals. Non-metals are things like carbon, things like phosphorus, selenium, sulfur. You all know sulfur. I'm sure you've heard sulfur smelling before, but you didn't know, maybe you didn't know what it is. And you all know iodine, what iodine is. That I in green there. The iodine is there in salt. If you don't get iodine, you develop a goiter, that bump in the throat, which becomes big. That's a deficiency of iodine in the human body, right? So what they are saying is that non-metals are the opposite of metals, and most of them are liquid and gases. That's true. Non-metal elements are found on the right-hand side of the periodic table, right? They are saying right-hand side of the diagonal of the periodic table. So take note of the description. Sit down when you're now on your own. Go through it again. Look, which one is the right-hand side? Which one is the left? What were we talking about in class? Because now, when it's time for you to answer questions in a test or where, the time to think and do all of those things won't be there. The information must be on your fingertips, right? So take note of these small things. So with the few solid non-metals, they can be easily tested, right? Nah, let's go on. This one's not too much. So properties of non-metals. We all know this. Non-metals do not conduct electricity. They are dull. Some of them you don't see, we only smell. They are brittle, they break easily, right? when you just throw it away, it just falls, it just breaks immediately like it's glass. Right. Those are the properties of non-metals. And then here are non-metals, examples and classifications. There's carbon. But carbon is a different kind of classification because it becomes into two things. Right. Let's talk about this one in detail. Let me put my marker on and try to write. This one is split into two. It's split into graphite and it's split into diamond. Right. So carbon, depending on how the atoms group together, it's graphite. Graphite is that thing that you use to write with on a pencil. That pencil thing that writes the ash, which is blackish, that's graphite. Right. Diamond, you all know diamond. That's one of the most hardest and most expensive jewel on earth. Right. So carbon is black, obviously. It's charcoal. That's why it makes graphite. And graphite sometimes is used as a lubricant in motors. Right. That pencil, you see, it conducts electricity fast, but at the same time, it's not hard, it's soft. We all know pencil. You can even scrape it with a razor without difficulty, right? Charcoal also is part of the additive for vulcanization of rubber. That's the use of carbon. They left out the diamond part there. Depending on the structure, carbon also makes diamonds, right? And then we all know silicone because everyone is carrying a silicone item in their pockets. They are using one right now. Computer chips, cell phones, etc. All those is made of silicone. All the power stereos, your home theaters, there, your sound systems in the car, etc. That's all silicone chips. All these computer chips there, they come from silicone. All right. And then last one, they're talking about sulfur. It's yellow and it's got a funny smell because it has this smell of wanting to make people puke, vomit, something like that. Right. That's sulfur. It's yellow in color. That's used for medicines and creation of acid, especially sulfuric acid. I know you've heard of it. Sulfuric acid. For those who watch movies a lot, you see them pouring an acid on the face and the person is screaming, "Wow, you put acid on me." This is the thing, sulfur, right? So far, so good. Can people hear me? Can I keep going on?
Yes, you can go
Yes, you can
on.
continue, sir.
All right, thanks, guys. Now, elements inside the diagonal of the periodic table are called semi-metals. Listen to this thing, elements inside the diagonal of the periodic table. Now we say the left-hand side and right-hand side. Now we're saying inside the diagonal of the periodic table are called semi-metals or semiconductors because they have properties in between metals and those of semi-metals, right? So here they were trying to make it more clear for you, right? As you can see, non-metals, semi-metals, metals, the periodic table, right? And the diagonal that you can see that we've been talking about here, like there, diagonal, right? And then the representation, those inside are called semi-metals, non-metals, metals, right? This is what we've been discussing now. And down there, we see it, we have lanthanides, we have radioactive lanthanides, we have radioactive materials like uranium, etc. Right? So the periodic table is an alphabet list of the universe as A to Z in alphabet. We talked about this in all language. That doesn't matter. And then this is the most important part that I introduced in the beginning with force, but now they're explaining it, they are putting it more clear. Group 1 elements, all right, those are the elements which are on the extreme right, with those ones which we said they are alkaline, which when you pour them in water, they're explosive. They react in an explosive matter, right? So group 1 elements lose 1 electron to become like noble gases. So on the outside there, we're describing that electrons sit on the outside like this, right? So what they are saying, these people, they are saying that for group 1 elements, they only have 1 electron out there. So in order for them to be stable, they have to lose this electron to be like noble gases, those ones which are like helium, which float in the air. When they are saying about to be like become like noble gases, they are talking about stability. When these group 1 elements have an extra electron which is on the outside, this extra electron is the one which makes them react explosively, right? It wants to break away. It's the one that makes them react explosively. Hence, in order to gain stability, they have to lose electrons. So the idea is that electrons must be repaired. Guys, I can't hear. There's a problem. Can you hear me? Yeah.
Helele, mute bani.
Thank you. Can you hear me now?
Yes, we can.
I can still hear somebody who's using there's something somewhere. It's giving us interference. Are you done?
Asiphelele can mute yourself.
Right. So what I was saying, guys, was that these group 1 elements have to lose an electron in order to be what? To be stable. So it goes on for elements in group 2, they have 2 electrons outside, right? Let me find my marker. And let's clear that. These ones, they have 1 electron outside. These ones, they have 2 electrons, and so on and so on and so on. All right. Guys, I can't continue now when it's like this. I don't know who this is. I'm having a problem continuing now. Let me try to mute him myself. Who's it? Let me scroll here and see if I can find it.
He muted, sir. He muted.
Muted, okay. All right, thanks, guys. That's better. Now I lost my mojo. All right. So what I was saying, guys, is that and so on and so on. These metals, they have electrons on the outside, going on and on and on and on and on. But there are rules now as to how these electrons must be charged, to how they must react, to how they must go about. Right. So let's go on to the next page. Properties of materials. We now have to talk about strength. When we're talking about strength, we're talking about how good the material is at resisting being altered in shape or form when a force is applied. That's what we talked about there when she answered about being malleable or malleability. Now there's another one called tensile strength. Right. This is the ability or force needed to pull the material apart by breaking the bonds between atoms. So have you seen that bridges are sometimes held by steel cables? Those steel cables will be taut, like when I'm saying taut, they'll be strained like being pulled, but they don't break. So that's tensile strength. Some metals have a high tensile strength, right? And then there's what is called compressive strength. That's the ability to resist being crushed. You see, when you try to crush something or try to squeeze it down and the resist is the same. Concrete is the ability of resisting what? Compressive, to be compressed. But you see that concrete now, it's now a mixture of what? Of iron mixed with cement. So it's a mixture of two, right? To try and bring about that what is it called? The compressive quality, strength of that two. Okay, let's go on to the next. Are we done with my pen? I'm going too fast. We've finished the properties of metals. It means that I have to open another lecture. Any questions so far, guys? Are you there? Hello? Hello?
So it doesn't look
Yes,
like anybody has questions.
Oh, all right. So far, so good.
Oh, sorry,
Next?
sir.
Yes.
In regards, do you mind if I go off topic for a second?
Yes.
In regards to the coming to campus for our assessments and stuff, our pracs, you said
Yeah.
you were gonna upload something on Learn for us to put our names down.
Yes. Yes, I'll do
Uh,
that.
And any idea by when? So we have an idea.
Wednesday.
Okay, perfect. Thank you.
Wednesday. All right. Now, any other questions, guys? All good, right? All right. You have a wonderful day, guys. I'm far away from South Africa at the moment, but I'll be back tomorrow. I'm moderating in Zimbabwe, in this University of Zimbabwe, but I'll be back tomorrow. Otherwise, have a wonderful day. Have a wonderful day.
Thank you, sir.
Bring next thing to Zimbabwe.
Ah,
Hey,
it's
sir.
too hot, my friend. I'm already crying already.
Bring
I'm
next
suffering.
thing.
It's 9 o'clock, but the sun is already something like 31 degrees. Just check on Google the weather there. You will see that there-
Yo,
it's like I'm being baked like a potato in an oven.
oh, say,
What Henneken from Zimbabwe?
All right, I'll bring you one. Have a
sorry,
wonderful
sir.
day. Yes,
Yes, can you please upload the notes on Learn?
yeah, I will open them up. They are already there. I just open them up after we cover them. I'll open them up.
Oh,
Oh, sorry,
okay.
sir.
Yeah.
So how can I access the first lecture on Zoom?
First
Guys,
lecture, I posted it online, the video.
it
Yes,
requires-
you did, sir.
Yeah, go and learn Moodle, learn 2022. It's posted there, the video.
Just click on the link and use the password that's sent that's on Learn,
Yeah.
and then you'll be able to download the videos.
Oh, okay, thank you.
Okay, guys. Anything else, guys? All right. It seems we are all good. All right. You have a wonderful time, guys.
Thank you. You as well, sir.
Bye, sir.
Bye.
You say you must bring it to Zimbabwe. He's bringing a Henneken there. We'll see. All right, I'll bring it.